In Chapter 4, we're going to talk about covalent bonds. We talked about ionic bonds previously. Covalent bonding, if you recall, as we said before, is where we share electrons between two or more atoms. And those two electrons are going to enable each individual atom to think it has the octet. Now, of course, hydrogen in this case only has 2 electrons because that's all that hydrogen can hold. A covalent bond is a 2-electron bond. So that is, if you see the 2 electrons that are being shared here, or sometimes you'll see that written like this, that dash right there equals 2 electrons. Okay, so make sure you keep that in mind. A molecule is what's formed from this covalent bond. 1 or more covalent bonds, okay? So when you see the word molecule, that's basically a covalent compound. So when we are putting these things together, we're using the valence electrons. So I've drawn these valence electrons for you here. The unshared electron pairs are called nonbonded electron pairs, or also lone pairs. And lone pairs typically do not get involved in the reactions. What do get involved in the reactions are the non-bonded electrons, or the unshared electrons. And so if you look at hydrogen, one of the reasons hydrogen so readily reacts with so many things is it has one unpaired or unshared electron that's ready to hook up with whoever is out there with another unshared electron. Fluoride, however, has 1, 2, 3 non-bonded electron pairs, okay, or lone pairs, that are not going to typically get involved, but it does have 1 unbonded electron, and so that's the one that's available to share. And so when those 2 atoms, hydrogen and fluorine, come together, they are going to share those electrons between them. So hydrogen brings 1 electron, fluoride has that 1 valence that's available, and so they share those 2. That leaves 3 lone or unbonded pairs still attached to the fluorine molecule. And notice here we have that line which equals that 2 electron covalent bond. Atoms share these electrons because they want to have the octet, as we said earlier. Now hydrogen only needs 2, so it's happy thinking it has 2. So when I have this one, I have HF. Okay? When I have HF, I have hydrogen, thinking that it has 2 electrons in that bond that it's sharing with fluoride. Fluoride has 6 electrons that aren't doing anything, and a shared 2 electrons that it's sharing with hydrogen for a total of 8 electrons. So hydrogen thinks it has 2 electrons, fluorine thinks it has 8 electrons, and so everybody thinks they have a full shell and both are happy. Okay? When we're looking at covalent bonding and how these are put together, we use these dots that you just saw me using, where we're showing the valence electrons. We use those dots to show how things are coming together, how they're sharing some electrons, and how some electrons are these lone pairs or non-bonded pairs. And so the Lewis structure is what we use, and that's what we call this, the Lewis dot structure or Lewis structure. And so we draw all the electrons as dots, or you'll see us use the dashes, as I said, and each dash is 2 electrons. And so these are just some examples: methane, ammonia, and water, where we're showing you where the lone pairs are and where the shared bonds are. So this next section is it's an explanation from the book of how this goes together and how it's using these valence electrons to form bonds. And they can form one bond. They can also form 2 or 3 bonds. We call them a double bond or a triple bond, but only certain atoms can do that. If an atom has 4 or more valence electrons, it's going to make these bonds so that it can have this octet, as we said before. So it wants to have 8 electrons in its outer shell, unless it's like hydrogen that can only have 2. Okay, so these are the rules as they're presented in your book, and so I'm presenting them here as well. This is not my preferred method of doing this. I think I use what's called an NASB method, which is going to follow this, which is a little easier in my opinion. But basically, you're going to have the number of bonds plus the number of lone pairs equals 4. This is the way your book does it. Okay, and obviously we look at covalent compounds because that's what our body's made of. All of our proteins and carbohydrates and fats and fatty acids and things like that are made from these building blocks that are put together, these molecules that are what we call covalent compounds. All right, and so as I go through this, I'm going to, as I said, I'm going to show you the basics of what the book says, but I'm going to go through it very quickly. And then we're going to talk about the NASB method, which I think is a much superior method.